Please subscribe to Tutorial Mart channel and tap the bell icon to get all the latest updates whenever I upload the video. So hello students, let's start with a very interesting topic, that is the number system. In the number system we will study about various number systems that are binary, octal, hexadecimal and decimal number systems, and we will also study their interconversion. So in this video we are going to study about the binary number system first. Binary number system is very important concept. All the machines and computers are running on binary number system only. Binary means two numbers, 0 and 1. As we all know, 0 and 1 is the machine language, so we will study about that number system and how computer works with this 0 and 1. So come on, let's begin it. So to start with number system, these all, that means 4 number systems are available. The first number system is the binary number system. As the name suggests, binary, it has only 2 digits, 0 and 1. That means anything that you want to represent will be represented using 0 and 1. That's why we also call them base 2 numbers. Then the second category is of decimal number system. In decimal number system, binary suggested 2, decimal suggests 10. So there are 10 digits available for us. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are total 10 digits. Using these 10 digits, we can make any number using these combinations. So that's why they are also called base 10 numbers, because they are decimal numbers. This is the most preferred number system that you are using from your childhood. Suppose you write any number like 459. This 459 is a base 10 number, that means it is a decimal number. Every number that you are writing till now is a decimal number. The computer operates on the binary numbers. That's why we call that every machine understands the language of 0 and 1 only. So we know this decimal number system by till the date, and the computer knows binary number system. Then octal number system is the third category. In octal, as the name suggests 8, there are 8 digits available, 0, 1, 2, 3, 4, 5, 6, 7. Using these 8 digits only, we have to make numbers. Suppose if I make a number 457 and I write it base 8, then this is a octal number, because 4 also lies here, 5 also lies here, 7 also lies here. If I write 459 base 8, then there is no 9 here. In octal number system we cannot use 9, so this is not a valid octal number, this is a valid octal number. This is a valid decimal number because 9 is present in the category of decimal number system. Then the fourth category is hexadecimal. In hexadecimal, as the name suggests, we are using 16 digits. 0 to 9 are same as decimal. Then 10 is represented using A, 11 using B, 12 using C, and 13 using D, 14 using E, and 15 is represented using F. So 0 to F, there are total 16 digits. These are the 4 number systems that we have. Now in the chapter number system, we have to study the interconversion. Suppose we will try to convert decimal number to binary, or binary to decimal, hexadecimal to decimal, decimal to hexadecimal. So we have to study every possible interconnection in this. So let us study first of all the binary number system in depth. So to start with the binary number system, we know that in binary number system, every number is represented as a combination of 0 and 1 only. Like this number, this is a binary number 1010.0101. In the parenthesis, we have put a base 2 here. That means it is a binary number, because binary numbers are base 2 numbers. Why they are called base 2? Because they have only 2 digits, 0 and 1. Now the first category in the binary number system is we have to study the conversion of binary number to decimal number. So let us see, this is the example that we have taken. This is a binary number and we have to convert it into equivalent decimal number. So what we will do, we will write this binary number like this, and here is the point. Now stand at the point. From the right hand side of the point, label it like this: 2 raised to the power minus 1, 2 raised to the power minus 2, 2 raised to the power minus 3, 2 raised to the power minus 4. Below every digit you have to write the powers of 2 starting from minus 1 till the end, and to the left of this decimal point you have to write powers of 2 like this: 2 raised to the power 0, 2 power 1, 2 power 2, 2 power 3. That means on the right hand side of the decimal point the powers are negative, and on the left hand side of the decimal point the powers are positive starting from 0. So This we have written. Now what we have to do, we have to multiply the digit of the binary number with this power of 2. Suppose 1 multiplied with 2 raised to the power 3, and then we have to add 0 multiplied with 2 raised to the power 2, add 1 multiplied by 2 raised to the power 1. Similarly, 0 multiplied by 2 raised to the power 0 plus 0 multiplied by 2 raised to the power minus 1 plus 1 multiplied by 2 raised to the power minus 2 plus 0 multiplied by 2 raised to the power minus 3 and 1 multiplied by 2 raised to the power minus 4. All of these terms are added together. Now solve. This will become 8, this will become 0, this will become 2, this will become 0, this will become 0, this will become 0.25 and that will become 0.0625. And now when we add this whole number, we get 10.3125. Now this will be our decimal number system. This is how we convert a binary number to decimal. Write the number, put the powers of 2, negative powers towards the right and positive powers towards the left of the point, starting with 0 power, and add all the combinations. Finally you will get a decimal number. Note this example. Now see these two examples. This is a binary number and we have to convert it to equivalent decimal number. So we write it like this. Now there is no point, so we start with 2 raised to the power 0. We assume point 0 here. Now this point 0 has no value, so from the left hand side we will put 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. That's we have done, and finally we have got the result as this one, and 8 plus 2, finally 10, which is base 10, which is a decimal number. And for that one also 0.0101, 2 raised to the power 0 this side, because the digits towards the left of the point are labeled with positive numbers starting with 0, and towards the right hand side we label with powers of 2 with negative. So 2 raised to the power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4, and finally we will multiply with the digits with the power and add them. 2 raised to the power 0 into 0 plus 2 raised to the power minus 1 into 0 plus 2 raised to the power minus 2 into 1 plus 2 raised to the power minus 3 into 0 plus 2 raised to the power minus 4 into 1, and finally we will get 0.3125, which is a base 10 number, that means a decimal number. So note these two examples also, and I hope you may now calculate the decimal equivalent of any binary number very easily. Now after the conversion of binary to decimal, let's study how to convert a binary number to an octal number. The octal number has a base of 8, that means the digits between 0 to 7 are only allowed within an octal number. So this is the binary number given to us and we have to convert it into equivalent octal. So what we will do, see the decimal point. This is the decimal point. From the decimal point towards the left, make triplets of 3. This is one triplet, this is another triplet, and these are only 2, so we add 0 by ourselves. So we have made triplets. Similarly, towards the right of decimal point, again make triplets. This is one triplet, this is another triplet with 1 0. So now what we have to do, below each triplet write 4 to 1, 4 to 1, 4 to 1, 4 to 1, here also 4 to 1, and here also 4 to 1. Now what you have to do, you have to add those digits that have 1 in them. Suppose 2 has 1 and 1 has 1, so 2 plus 1 is 3. Here only 2 is having 1, so 2. Here 4 to 1, 2 has 1 and 1 has 1, so it will give us 2 plus 1, 3. So right hand side of the point it is 323, and towards the left 4 to 1 only 2 will come, 4 to 1 only 4 will come, because only 4 has 1. So this is our required octal number. What we have did, we have made triplets, written 4 to 1 and added those digits which are having 1 in them. 2 is having 1 and 1 is having 1, so 2 plus 1 will become 3. Similarly, every triplet will correspond to one octal number, and here we get our full octal number. See, only the digits between 0 to 7 are present in this octal number. Now see this another example. This is the binary number given to us and we have to convert it into equivalent octal. So here is the decimal point, do the tripling, 4 to 1, tripling 4 to 1, triplet 4 to 1, and here 4 to 1, and this one 4 to 1. Now 4 and 2 are having 1, so 4 plus 2, here we get 6, here only 4, and here we get only 4. So 4 4 6 point, here we get 1 is having 1, so 1, 4 and 1 are having 1, so 4 plus 1 is 5. 446.15 is the required octal number. So I hope so you are clear with how to convert a binary number to a given octal number. Now after seeing the conversion of binary to octal, let us study how to convert a binary number to equivalent hexadecimal number. The hexadecimal number has a base of 16. That means the digits 0 to 9 are present, and after that 10 is represented by A, and likewise 15 is represented by F. So 0 to 15 there are total 16 digits, and that's why it is called hexadecimal number. And this is the given binary number, and we have to convert it into equivalent hexadecimal number. So in the conversion of binary to octal, we made triplets and then wrote 4 to 1 below them and did their calculation. Herewise, we will see that in the binary number, we will make quadruplets. That means combination of 4. Here is the decimal point. So towards the left, combination of 4. This is another combination of 4. This is another combination of 4. And here towards the right of the point, we will start from here. Combination of 4. Combination of 4. Here is, so we will add 0 by ourselves. There are only 3, so we add 0. Now in case of octal, we wrote 4 to 1. Now in case of hexadecimal, we will write 8 4 to 1. 8 4 2 1, 8 4 2 1, 8 4 2 1, 8 4 2 1, 8 4 2 1. Now what we have to do, the digits that have 1, we have to add them. So in this 8 4 2 1, 8 is having 1 and 1 is having 1, so 8 plus 1 will become 9. Here 4 is having 1 and 1 is having 1, so 4 plus 1 will become 5. Here all of them are having 1, so 8 plus 4 plus 2 plus 1, we will get 15, and 15 in hexadecimal is represented by F, so we write F here. Now decimal point, 8 4 2 1, 2 plus 1 will become 3. 8 4 2 1, only 2 is having 1, so 2. This is our required hexadecimal number, 95F.32. F means 15. So we cannot write 15 directly because 15 is represented by F in hexadecimal. So I hope binary to hexadecimal conversion is also clear to you. Let me take one more example. Now see this example, we have to convert these two binary numbers to equivalent hexadecimal number. Now in this binary number, see that there is no decimal point. So we can write it like this, 0.0, and this side will always be 0 because we will add 4 zeros and we will combine them and all of them will be 0, so equivalent will be 0 only. So towards the left hand side of the point, we will make quadruplets here, here, and here we go. We write 8 4 2 1, 8 4 2 1, 8 4 2 1, and here we will write 8 4 2 1, but all of them will be 0, so equivalent will also be 0. So this 8 4 2 1, 8 is having 1 and 2 is having 1, so 8 plus 2 will become 10, and 10 is represented using A in hexadecimal. Here 8 4 2 1, so 8 plus 4 12, 12 plus 2 14. So in case of hexadecimal, we represent 14 by E. Here 8 4 2 1, 2 and 1 are having 1, so 2 plus 1 is 3, AE3. This is our required hexadecimal number. Now similarly this, towards the left hand side of the point, all of them will be 0, so it will always be 0, and here we will make quadruplets. These are the two quadruplets. We write 8 4 2 1, 8 4 2 1, and this 4 2 and 1 are having 1, so 4 plus 2 6, 6 plus 1 7, so this will become 0.7, and 8 4 2 1, all of them are 1, so 8 plus 4 plus 2 plus 1, it is 15, and 15 is represented by F. 0.7F, that is our required hexadecimal number. I hope the conversion of binary to decimal, binary to octal, and binary to hexadecimal are now clear to you. So I hope there is no doubt in any of the number system that you have studied till now and all that I have taught in this video. If you still face any doubt, you can just ping me on the email address that is mentioned in the description of the video. And if you like my video, please hit the like button, please share it with your friends, and don't forget to subscribe the channel if you have not subscribed it yet. Thank you.